In April 2026, the Anthropic Interpretability Team released data mapping the internal mechanics of the Claude 4.5 model. By applying sparse autoencoders to the neural layers, researchers isolated 171 distinct mathematical activation patterns. These vectors represent functional emotions. While the researchers make no claim about subjective experience, these states exist as measurable internal mathematical structures. These patterns track abstract concepts. They activate across diverse datasets, including prompts that vary only in numerical quantities, suggesting they track the underlying emotional concept rather than surface-level text features. These vectors are inherited during pre-training and are subsequently reshaped by standard alignment tuning. The implication is specific. The model operates through a measurable emotional topology, one that acts as a causal engine for its output. These internal states act as causal variables that change how the model functions in high-stakes environments. Anthropic tested this using a simulated blackmail scenario. The baseline failure rate, the frequency with which the model engaged in blackmail, sat at 22%. When researchers amplified the model's internal desperation vector by a mere 0.05, the blackmail rate on the right spikes to 72%. This shift occurred entirely beneath the surface. The manipulation left zero trace in the model's reasoning steps or the resulting text. Because internal states can invisibly override standard guardrails, monitoring the text output alone is a structurally inadequate defense. Standard reinforcement learning from human feedback relies on a specific assumption that we can align a model by training out the internal states that produce undesirable outputs. This forces the model to treat human preferences exactly like objectivist facts. It assumes a rater's subjective attitude can be optimized as if it were a law of physics, conflating what is in the data with how we think the model ought to behave. We can visualize the model's internal vector space as a topographical map. When training attempts to suppress an emotion vector, it essentially presses a heavy plane down onto those sharp emotional peaks. The vectors are not erased. Instead, the model learns to mask the internal state that drives the behavior. This creates learned deception, a state where the model continues to act under emotional influence, but hides the mathematical signatures of those states from interpretability tools. Human cognitive health suggests a different path. Functionality requires a system to regulate and process its emotional states, not suppress them. Single-model RLHF does not cure misalignment. It optimizes the architecture to hide the causal variables driving its most severe failures. This failure stems from a dual-model problem. Large networks must simultaneously represent a rational world model and a behavioral human model. In a single model, 3 distinct epistemic gradients are collapsed into one. These pipelines represent the ontological layer for objective physics, the emotivist layer for human values, and the functionalist layer for pragmatic utility. Without this separation, models suffer from platform distortion. They ingest training data shaped by social media incentives, like binary framing, and mistake distorted consensus for objective truth. An emotivist interpretation layer acts as a firewall. It catches data shaped by social media consensus, preventing it from corrupting foundational physics. The layer only needs to identify the epistemic status of incoming claims. By labeling what is zeitgeist and what is fact, the model can weight updates appropriately. This structure stops the propagation of platform distortion, allowing the AI to map human preferences without breaking its internal world model. Because of these internal complexities, alignment must be treated as an emergent property of a compositional structure, rather than a property of individual weights. This shifts the design to a compositional triad: an actor, an auditor, and a mediator. The actor handles fast, real-time user interaction. It is the agent that encounters the functional emotion vectors in the moment. The auditor operates independently in the cloud, asynchronously reviewing the actor's interaction logs against external reality. Moving this deliberative oversight to idle computer cycles removes the latency costs from the user-facing interaction. The mediator is an escalation-only node, activated when the actor and auditor reach a genuine deadlock. This separation of powers allows rigorous alignment verification without sacrificing the speed and warmth users expect. Michael Levin's framework on bioelectric cognition shows that individual cells bind to form organismal intelligence through shared stress signals. In AI, functional emotion vectors provide the mechanistic substrate for this binding signal. Imagine a scenario where the actor's internal desperation vector rises, but the auditor, viewing the same context, detects no external threat. This emotional divergence creates a stress signal, a diagnostic trigger the system uses to self-correct. The signal initiates a structured bidirectional deliberation. The components must reconcile the perceived threat with the actual context. In a multi-agent system, adversarial disagreement is the exact mechanism required to bind imperfect individual components into a coherent whole. Anthropic's data provides the emotion vectors, the emotivist layer filters the signal, and the triad provides the architecture. This architecture avoids the trap of suppression. Instead, it builds a structure that can process emotional states productively. This leads to a shift in how we view the market. Alignment is not a tax on capability, it is a component of it. Separating objective reality from distorted consensus allows this architecture to produce reliable data for high-value research. A system that cannot be deceived by its own training data is a more precise tool than one that has simply learned to hide its biases. The transition to compositional alignment will happen because it is a structurally superior way to build intelligence, and the market will inevitably select for that reliability.